Hi there. Recently I decided to retire the old cheap toolbox multimeter in the garage and replace it with this one to get something safer. It is from RS Components and part of their in-house brand called RS Pro. The model number is RS-14 and it costs £26 delivered including tax. Here's a summary of the features and specs. The RS-14 is in the right column. As you can see, it has more features, but it's slightly worse in accuracy compared to the manual ranging RS-12. I would have been happy with a manual ranging meter, but the RS-12 has a lot fewer AC voltage and current ranges. I'm very aware that for that money you can get a lot more multimeter spec and claimed accuracy from sites like Banggood and AliExpress, but in this case I want a meter with an actually true CAT rating in accordance with the EN 61010-1 standard. Many cheap meters from these sites claim all sorts of fantasy CAT ratings, but in no way are built and tested accordingly. The RS-14 is not a true RMS meter, it uses averaging. This is one of the reasons I selected it. Since the review of the RS-14 got surprisingly long, I decided to split the video in two parts. In this part I'm going to review the RS-14, and in part 2 I will specifically look at the differences between averaging and true RMS meters. With that out of the way, here's what you get. The meter in a fetching orange-black enclosure that I quite like, a set of probes, a 9-volt battery and a K-type thermocouple. Oh, and a manual, of course, which is in 17 pages of proper well-written English. It also contains a French, German, Italian and Spanish version. The German version is an obviously machine-translated mess from the English. I can't judge the quality of the other translations. On closer inspection, there are indications that this was built to a price. The bottom is hard plastic and rather slippery on my workbench. Only the two dimples at the front are softer plastic with a better grip. There's no protective rubber holster. On the front, while the LCD is recessed, the 4 buttons and the range switch knob are not and will bear the brunt of any fall. Let's open the battery compartment. At first I couldn't get it open. Let me show you why. I discovered a second screw cunningly hidden by the tilting bail. At least the battery compartment uses metal insert screws, which is nice. The usual 9-volt clip, and we can see 2 ceramic fuses, but they are so deep down that you would have seriously trouble getting them out from the battery compartment even with long-nosed pliers. But one thing you can do is using another meter to test if the fuses are still okay. On this brand new meter they obviously still are. Time to get the back off completely to have a good look at the inside. The housing is held together with 4 self-tapping screws. The back shell does not contain any shielding, which you often see in other meters. I like the deep groove that goes all around. It matches the large rim around the top part to make a very tight seal. The main purpose is of course as a blast shield to contain electrical arcs to prevent injury when you're holding the meter in your hand while measuring high energy circuits and something goes seriously wrong. I can't detect any cutouts or tracking slots on the PCB, but the tracks themselves seem to be spaced sensibly with wide separation. At the terminals is the usual flux residue from hand soldering the connections. The volts milliamp socket goes to a dark green PTC acting as a resettable fuse. The big blue component is kinda opposite of a PTC, it's a MOF or metal oxide varistor. The MOF starts to act like a short circuit if the voltage exceeds its rating, 820 volts in this one. The current will then cause the PTC to heat up and reduce the current. From this protection circuit, the track carrying the input voltage crosses the PCB, ending in 2 5 megohm precision resistors in series. one standing and one lying really long across the board. The divider network for the different ranges is made of discrete resistors, which is okay for this class of meter. Next we have lots of Smd resistors and two trim pots around the dual precision op amp, and a voltage regulator for the incoming 9-volt battery. Let's have a look at the 10 amp input. Extra solder to improve the connection between the shunt and the fuse. And there is a clamping network using two anti-parallel diodes. Then there is this arrangement of 4 diodes looking like a good old 1N407 rated for 1000 volts. This could be the full bridge rectifier for AC. As I explained before, this is an averaging meter and not true RMS. As for the brain of this whole thing, I can't make out any marking. In fact, the chip has a very strange mottled surface, as you can see if I shine a torch on it. Before diving into the range and accuracy tests, a quick look at the manual which you can download from the RS website. In general, the accuracy values of the RS-14 are nothing to write home about, but I knew that when I selected it, and you need to keep in mind that the meter is built at a cost and for use in mains electrical wiring, so in this case the Cat3 600 volt rating takes precedence. Let's start with the DC specs. The 0.5% of the DC 200 mV range has the highest accuracy of any range in the RS-14. The rest are all more modest. The maximum DC value is 600 volts. By the way, I always find this statement about maximum input voltage a bit confusing. A maximum of 600 volt DC is clear enough, but why adding RMS? A sinusoidal AC voltage of 424 volts RMS will produce 600 volts peak, and that is all this meter can handle in DC mode. Perfectly fine even for face-to-face measurements in 240 volt systems, as the Cat3 rating requires. Don't read RMS as if you could connect this to an AC voltage of 600 volt RMS, which would result in almost 850 volts peak and seriously overload the meter to the point that the MOF would already start shortening the input terminals. The same confusion on the AC specs. Theoretically, yes, in AC mode the meter should be able to handle 600 volts RMS, as long as you didn't accidentally switch to DC. Note the limited frequency range, fundamental mains frequencies only. The accuracy of AC volts is slightly worse compared to the DC, which is to be expected given the need to rectify first. Note that the AC 200 mV range is not in the auto ranging. You need to go to manual range and select it by repeatedly hitting the range key until the right range is active. They probably did this to reduce the amount of spurious noise shown by the multimeter when the leads are open. Another thing to note is the high plus 30 digit error in the 200 mV range. That's an error of plus minus 3 mV already all by its own. DC current and AC current specs are again not very exciting, especially the 10 amp AC mode. Resistance mode accuracy is what you would expect of this meter. Note that the input protection in this and the following modes is only 250 volts. I assume this is RMS, but I'm not going to risk the meter to test it. Last not least, the thermocouple, sadly with a resolution of only 1 degree, presumably so there wasn't a need for range switching with a 2000 count meter. Diode Test is using a rather low 1.5 volts given the 9 volt battery, so generally LEDs can't be tested using this meter, which is a bit of an oversight. And continuity mode supposed to beep at 100 ohms or less, which is standard in most meters. Enough of specs, let's get more practical and start with a quick voltage accuracy test using my DMM Check Plus reference standard. You may have seen it in some of my other videos. The first test is for DC volts. The RS-14 should read exactly 5 volts. 4.97 volts is 0.6% too low, but still much better than the spec would have allowed. At 1% plus minus 2 digits, 4.93 would have been just in spec. Switching to AC volts. The DMM Check Plus provides exactly 5 volts as a rectangular AC waveform, so it's no surprise that the non-True RMS RS-14 shows 5.52 volts instead. You can correct for this, as I will show in part 2 of this video, and after that the result is again accurate to 0.6%, much better than the specified AC accuracy of 1.5% plus minus 3 digits would have you expect. I do have another voltage standard based on the 8588. It confirms the 0.6% error of 4.97 instead of 5 volts we have seen from the DMM Check Plus, and the 9.94 reading instead of 10 volts is exactly the same 0.6% error. Moving to DC current. The DMM Check Plus provides an accurate 1 mA reference current, which the RS-14 reads exactly using its milliamp range, occasionally dropping 1 digit. Let's see what the microamp range makes of it. 0.995 milliamp. The exact value should have been 1.0002 milliamp, so we are just 0.5% too low. An excellent result for this meter. On the AC side, we have the same situation as with volts before, caused by the non-sinusoidal waveform. Corrected for this, the current would have been 0.97, which is 2.7% too low, but within the stated tolerance if you factor in the plus minus 5 digits. Let's see if the microamp range can do any better. 1.109 milliamp, which when corrected is equivalent to 0.998 milliamps. That is less than 0.2% off. Again, this is an excellent result. The DMM Check Plus has 4 precision resistors, but for the RS-14 I'm using my own standard, which offers 9 values if you don't count using resistors in series. First off, there is no rel or null function, so we need to find out the resistance of the leads. Okay, nice enough, it seems to compensate for that. Let's measure 1 ohm. Very odd behavior, counting up like that. 0.9 ohm. That is 10% off by value, but only one of the plus minus 4 allowed digits, so technically in spec. 10 ohm. Again this strange counting up. 9.8 ohm, off by 2% or 2 digits. 100 ohm is spot on. 1 kilo ohm is spot on. 10 kilo ohm off by 0.1%. Same for 100 kilo ohms. And 0.3% off for 1 meg. And 0.1% off for 10 meg. And 100 meg is outside the spec. Apart from the weird counting, not too bad. Except for the lowest 200 ohm range, the accuracy is very good, much better than the spec. The diode test works as expected. This should also work with 2 normal diodes in series. But as expected, diode test even with a low voltage red LED doesn't work. That's because it uses only 1.5 volts for this test, as we can easily confirm with another meter. The second mode of diode test is continuity. Oh dear, that is pathetic. It takes forever to recognize a short. I wonder if it's those probes that cause the trouble. I replaced the probes with those from the Compartment BM235, which is super fast in continuity mode. That improves it possibly by a tiny bit, but it's no comparison on how a good implementation of continuity should be. Here's the Compartment BM235 for comparison. Super fast. It's not the probes, the RS-14 is simply very slow in detecting continuity. Speaking of probes, the supplied ones are rated Cat2 1000 volts 10 amps and come with removable shrouds. The probe material feels a notch up from the really cheap ones. And the 3.5mm diameter leads are rated as 18 AWG 2000 volts 80 degrees Celsius, but not using silicone and relatively stiff. For completeness, here's the temperature probe of the RS-14. The readout can be changed to Fahrenheit and is always in full degrees. By now you probably have noticed that the RS-14 doesn't display 0 in its AC and DC volt ranges if nothing is connected. The auto ranging selects the most sensitive range, which then picks up strange voltages from the open leads. However, this is not a problem when connecting the leads to measure something, or even just shorten them. And the same for DC. Shortening the leads zeros the display. Here's another function of the RS-14 I rather like, and that's the max button. Imagine you're trying to note down a measurement, but you need both hands, or maybe you can't afford to take your eyes off the correct positioning of the probes, like deep in a mains bus bar. Take this battery as a harmless example. As with most meters, the RS-14 hold function is useless because you need a free hand to press it while the value is still displayed. The max function works by always showing the maximum value. So in this case, I can turn on max, measure the battery, then drop the probes while the measured value is automatically frozen on the display. To turn it off, press max again. Yes, it only records the maximum, but still, it will surprise you how many cases this simple function is as useful as a proper auto hold function of much more expensive multimeters. Max works on all AC and DC voltage and current ranges, but sadly not on ohm, diode or temperature. I like the relatively large display of the RS-14 compared to other meters in the same price bracket, but the minus point is the display viewing angle. Here it is lying flat on the table and the camera is about head height, being relatively close and therefore looking steeply down onto it. Yet you can already see the other segments ghosting. Ghosting goes away if you reduce the angle and look straight onto the display, but if the angle is just slightly longer, for example, looking at the meter lying on the table from a normal, easy within reach distance, the ghosting is so bad you can't read the display any longer. So more likely than not, this meter needs to be propped up on its tilting bale, which, because it's still new, isn't the easiest to get out. One-handed operation is possible, as you can see, and the tilting bale is reasonably sturdy. More of a problem is that the stand and the bottom part of the meter are both made of hard plastic and therefore tend to slide around. Next up, test of the low battery indicator. Here the RS-14 is powered from an external power supply with the voltage shown on the big meter. I'm going to use the RS-14 to measure one of my reference voltages occasionally to see if the reading changes as the battery voltage drops. At 9 volts we have the familiar 9.94 as confirmed earlier. Dropping to 8 volts and everything is still fine. Same for 7.5 and 7 volts, no problems. Below the minus sign you can just make out a very faint low bat symbol coming on. Dropping gradually to 6.5 volts, the low battery symbol becomes more prominent, but the RS-14 measurements are not affected. Down to 6 volts now, no problems. Same for 5.5 volts and even just 5 volts. I decided to turn it off and on to see if it will start at such a low battery voltage. No problems and the measurements are fine. Down to 4.5 volts and still fine. Same for 4 volts. Doing the off-on test to see if it restarts at 4 volts battery. No problems. 3.5 volts still going. Dropping down to 3 volts and strangely the low battery symbol is starting to fade away. Hmm, 9.95 instead of 9.94. Is this the first sign of additional inaccuracy caused by the really low 3 volts instead of 9? It does start up at 3 volts and the measurement of 9.95 is consistent. Dropping to 2.5 volts and the low battery symbol has indeed faded away completely. And what do you know, we are back to 9.94. It does start at just 2.5 volts and measures just fine. If you didn't know, you would not suspect this meter as having a battery voltage of just 2.5 volts. Okay, at 2.3 volts it finally gives up. This meter can be used until just about when the low battery symbol starts to disappear at around 3 volts. It definitely allows you to make full use of every tiny bit of charge left in the battery, and if you use rechargeable ones, the first full appearance of the low battery at around 6.5 volts or so would be a good reminder to recharge. So how much current does it draw from the battery? In this test the large multimeter is measuring the current drawn by the RS-14. Current in the AC volts mode is just below 3 milliamps. DC volts is slightly less at just over 2 milliamps. Ohms about the same. And so is continuity, except when the beeper is active and current jumps to 13.5 milliamps. All other modes use about the same current as the AC volts, just below 3 milliamps. At this rate, with a normal 9 volt cell, you should be able to get around 160 hours of operation. Backlight clocks in an additional 5 milliamp or so on top. The meter has automatic power off, which you can't disable. To test it, the large meter shows the consumed power and the timer on the right the elapsed time. Apologies for the blur, I accidentally knocked the focus off while waiting, but you can just make out the numbers. At 13 minutes 44 the meter gives a warning beep, and 1 minute later it beeps again and turns off. The current drops and settles at around 4 microamps. Well, 4.87 microamps to be precise. Very low indeed, so no worries if you accidentally left the meter on. In this test, all 3 meters are connected in parallel to measure mains voltage. The other 2 meters are True RMS, while the RS-14 is averaging. The RS-14 is within 0.9% of the others, which is well within spec. If your AC measurements needs are just household mains, there is no need for True RMS. In industrial estates with lots of high power motors or when measuring power converters, AC waveforms are no longer nicely sinusoidal and things will be different, as we shall see in part 2. For now, let's keep AC limit to sine waveforms. Instead of the form, we can of course change the frequency, although the meter is specified only for 50-60 Hz. Here it is sandwiched between the AN8008 and the BM869S. The BM869S shows the frequency on its second display. Starting with 50 Hz, and the RS-14 is within 0.5% of the other meters. At 100 Hz everything is still fine. Same at 200 Hz. At 400 Hz we have a loss of 1 digit and the error has increased to 0.85%. At 700 Hz we have lost another digit and are in the 1.1% error range, but nothing further happens all the way to 1 kHz. At 2 kHz we are at 1.5% error. At 4 kHz the AN8008 is down to half the value, so 50% error, while the RS-14 is still showing a reasonable value at only 2.8% error. At 6 kHz the AN8008 is basically zero, while the RS-14 is still within 4.1% error. At 10 kHz the RS-14 is 8% off. So basically up to 1 kHz you will have about 1% error, and at 10 kHz it's still within less than 10%, but I would not go any further. I ran a test similar to the one you just saw, comparing meter readings of the RS-14 against the reference, but in this time for different AC voltage using fixed 50 Hz sinusoidal AC from 36 mV to 240 volts, using my Agilent 3441A as reference. I don't bore you with the actual run, let's just look at the resulting plots. The top diagram shows the whole test range, and the red trace is the RS-14 error in percent against the reference meter. The lower diagram is a zoom in of the same data covering just the range from 0 to 2 volts. The increase in error at the low side is typical for these kinds of tests and caused by the fact that the significance of just 1 digit off has an increasing effect on the error percent on the lower the value becomes. This causes a steep rise in error, which is caused by limits on resolution and not a problem with the accuracy itself. In the lowest range the RS-14 would show 1 mV as 1.0. If he gets just 1 digit wrong to show say 0.9, that is an error of 10% at that voltage. I talked about this effect in many of my previous videos, and you will see it a lot more in this one, so I won't point it out specifically in each instance. Overall the error varies between plus 0.5% and minus 1.86%, with the average at just below minus 0.5. As you can see, most of that large variance is coming from the 0 to 2 volt range, for reasons I just mentioned. So if we just look at the 2 volts to 200 volts, things look a lot better. The average is still around minus 0.5%, but overall the variance is much smaller, and worst case it's around minus 1%, which is still better than the specification. I ran a similar test for AC current from 13 milliamps to 5.8 amps. My best reference meter, the 3441A, only goes to 3 amps, so from 3 amps onwards the reference meter was the BM869S. Again, the lower graph represents the zoomed-in view up to 200 milliamps. Overall, the RS-14 stays just within minus 1.5%, which is in spec for the most accurate 200 microamp range. All higher ranges would allow 1.8 or even 3% for the 10 amps. So minus 1.5 across all is quite a good result. Moving on to DC voltages, and my test range was from 100 millivolts to 200 volts. The overall error stays below 1%, with an average of minus 0.62%, which is again a decent result for a meter of this class. Last not least, DC current. The test range was from 1.5 milliamps to 5 amps. As for the AC current test, from 3 amps onwards, the reference meter was the BM869S. Over the whole test range, the RS-14 stays within minus 1% with an average of minus 0.61%, which is in spec for the most accurate 200 microamp range. All higher ranges would allow either 1.5 or even 2.5% for the 10 amp range, so this is again much better than spec. Time to wrap things up for part 1. Here's what I dislike about the RS-14. It's very slow in the low ohms and continuity mode. The low ohms range has this strange counting effect that I have not seen at other meters, and to get a reliable beep in continuity mode you have to keep the probe shortened for more than a second, which is pretty bad. The Diode Test does not allow testing of LEDs because of its low voltage. Now that we know that the meter can run with just 2.5 volts battery voltage, this may be understandable. Auto power off can't be disabled, at least the manual doesn't mention it, and I tried the usual methods like keeping the range switch pressed while powering on, but it had no effect. The display viewing angle could be better. While the enclosure has good blast protection, it doesn't protect much against the rough life in a toolbox. Although the orange plastic is kind of soft, a rubber holster would have been so much more useful and also stopped the black hard plastic bottom to slide around on the workbench. On the plus side, it meets or exceeds its admittedly relative moderate accuracy specs. It has a very decent battery life, helped by the relatively low current and the huge tolerance for low battery voltage, although strangely below 3 volts the low battery symbol disappears. The RS-14 has a really good AC volts and amp range, 5 ranges for AC volts including 200 millivolts and 5 ranges for AC current down to 200 microamps. Most meters in this class have only 200 and 600 volt AC ranges, and many have no AC current at all, or maybe just a 10 amp range. I really like the max function. It works very well and it's incredibly useful and convenient as an auto hold. Okay, so it only works in one direction, but max is what you most often want anyway, and you can spend 10 times more on a multimeter and still don't get a proper auto hold. Last not least, the RS-14 offers decent protection to Cat 3 600 volts, which means it can even be used on some industrial estate installations such as distribution panels, motors and 3-phase appliance outlets. Definitely good enough for household use, which is all I'm planning to do with it. Well, that's it for part 1, the review of the RS-14. I'm still working on part 2, comparing the RS-14's averaging circuit with True RMS meters. Until then, thanks for watching.